All right, so next up we have Ket Brittain with his space qualified antennas. And
There you go.
Okay, we're going to talk about some of the problems you have when you're putting an antenna in space. We've got a few of these been floating around. These are an LNB. This is a complete down converter designed for narrowband services in Europe. These have been floating around for about $5 on eBay. I'm afraid in the last 24 hours that may have changed a bit since we got the information out to these guys. But this is AMSAT 1040N, comes out 462 megs on the one I tested. If you want to listen to single sideband, it comes out at about 380. And it is stable enough for CW and single sideband. This is your down converter. Now there's going to be a temptation to put this on a dish. You can't track a LEO with this on a dish. Hold your hand at length, look at your thumbnail, and that's the size of your beam, and you're going to hold that on a LEO. And if you say, I've got 10th of a degree resolution on my positioners, I've got the satellites and everything else, do you allow for atmospheric distortion? It bends. I've been tracking Oscar Zero with a 12-foot dish for many years. Oscar Zero, by the way, is the one that God put in orbit 4 billion years ago. Some of us use it even though the batteries are still dead. If it's not 500,000 miles, it's not really a DX contact. But we would see that moon, the optical moon and the radio moon, to be in two different places. And I asked Tom Clark about this. I said, well, you guys use the big dishes. If I have this with a 12-foot, what do you do? Oh, we track 4 quasars horizon to horizon, do a least squares best fit analysis. And our tracking program includes barometric pressure, relative humidity, and current air temperature. So good luck tracking it. What we're going to actually be looking at doing is coming up with some horn designs to go on this to drop the gain from 36 or 37 dB back down to about 20. That gives you a much broader beam. And as you can see, the horn is really easy to remove on this guy. And there's the information on the part number for it. Now, what I'm hoping we're going to be able to do, now that we know there's a lot of these out there, this is not the only one for narrowband services. There's a lot of other narrowband service LNBs as we track them down. If you know anybody who does a lot of satellite receive installations, let us know. Let's talk with them and see what we can find for some LNBs that are also for narrowband services. The ones for DirecTV are a phase lock DRO. They're okay when you're looking at something 500 megahertz wide. It doesn't work with narrowband signals. I want to cover this real quickly. This is a Vivaldi antenna. You can think of it as a cousin to the rhombic antenna. It's fed at the back, signal goes out the front. The width, the other button, okay. The width right here determines the highest. Well, I gotta see it too. The gap right here determines the highest frequency it works at. The width here determines the lowest frequency it works at. Making these work over a 10-to-1 frequency range is not a problem. They're very broad-banded. In this particular case, I put a dielectric lens out on the front and was making it circularly polarized. But that's not the objective. I just want to show that these form an antenna by themselves. Okay, this is the one that's been through a few variations. It started out on the left and they kept adding more bands they wanted it to work on. So this is a super secret design from the 1930s called a planar disc antenna. Very broad banded. On low frequencies, it's a fat dipole. As you go up, it kind of, I'll figure this out in a minute. Too complicated. I'll be using that one I want to use. Okay, as you go up in frequency, it turns into 2 Vivaldi antennas. So it's very omnidirectional low. As you go in, it kind of becomes more of an oval shaped pattern. Ideally, when we put one in orbit, it'll be positioned about like this, flat. Now the energy will be going at the horizons, so a person directly underneath and a person over at an angle will be getting similar amounts of energy. Then they said, well, this is going into the EDIS. This can also become the 435 meg backup antenna. So right here we have a little inductor that is the base load for a top hat vertical, and it also becomes an RF choke to keep the microwave signals out of that antenna. So now it's also now the 435 backup, in addition to being the L-band, S-band, C-band, and in theory, it works up to 26 gigahertz, which is really the limit of the SMA connector. Here's a 10 gig. We've done quite a variety of these. These are on space qualified PC board material. Did an interesting trick on these. I picked a length width ratio that gives the feed point impedance here to be 100 ohms. So I have 100 ohms, 100 ohms, and they meet at a 50 ohm trace. The 50 ohm trace tapers to 100 ohms twice, and now I'm back to 50 ohms again. So the impedance matching is tapered lines and the shape of the patch, that's the word I was looking for, itself. This was the first antenna I put into orbit. It was initially made as an ILS antenna for a business jet. The owner of the company had been an F-14 pilot, so it was Tomcat Aviation, and as you can see, we got two little F-14s on it too. He thought that was extremely cute. Depending on what components we put here, this can be tuned anywhere between 50 megahertz and 400 megahertz. Your choice. Also, we have where you can put an inductor and a capacitor in series, and those become notch filters. So you can tune this to one frequency and simultaneously notch at the antenna two other frequencies. Well, got a call from a group down in Austin who was building a CubeSat, and they needed a 137 meg antenna. This was going in a getaway package on the Space Shuttle Endeavour. Do you know how much paperwork there is when you put something on a man-rated spacecraft? Fortunately, this is on Arlon 25N PC board material, which is space qualified, and was used inside the cabin of the space shuttle. So that saved me about 5 pounds of paperwork. But because it was going into a getaway package, they couldn't put anything external to the CubeSat. So this became a conformal antenna to this CubeSat. And I think we were checking with somebody yesterday, can we make this twice as long and tune it down to 10 meters? And the answer is probably. When it's you drive it right here, so it's a combination inverted F and loop antenna. And again, by choosing what components can go here, you can tune it over a broad range of frequencies and get rid of two others. One thing I want to make real quick here is on space qualified. They are very, very, very finicky about outgassing. Normal PC board material in space outgasses. It tends to collect on optics and solar cells. You're wondering why your CubeSat has suddenly had its TV camera develop glaucoma? You wondered why the solar cells are degrading faster than one would predict from the radiation? It could be outgassing from your circuit boards. So there's a lot to be said for taking your boards after you've finished and sticking them in a vacuum for a few days and go ahead and take care of the outgassing. This is one I'm currently doing for Moorhead Group, Moorhead, Kentucky, which we talked about doing a couple of, how exactly were you regarding that, Jerry? We're exploring partnerships with Moorhead for you guys. As for me, I'm already working with them. So they wanted a broadband antenna. This will be hinged at the back, held right here in the front, and is now deployed. This turned out to be not big enough for them. They wanted to go even lower in frequency, so the next one's going to be a little bit bigger and limited only by the size of the local PCB processing tanks. And yes, mass was an important consideration. Log spirals. A lot of guys start talking about these because, again, they have very, very broad bandwidths. Whoops, I'm going to figure these buttons out yet. How fine you can do the artwork in the middle determines the upper frequency. Outside diameter determines the lowest frequency. These have roughly 10 to 1 frequency spans. There are commercial ones that go as high as 40 to 1 frequency spans. The bottom one was originally developed for my own personal antenna range. I was doing a lot of circularly polarized antennas, and I needed to have a polarization reference. One of the problems with actually putting these together is the input impedance is like a transmission line. You don't have a hot and a ground. You have like twin lead, and I'm going to get this figured out yet. The input impedance, we need a bigger piece of foam on that. The input impedance is about 120 ohms. But I gotta see it. I know. We'll do it this way. Now I can see it and talk. Yeah, but now I can actually see what I'm talking about and point it out. Okay, this works out better. So right here we have an input impedance of about 120 ohms. Kind of hard to do with coax. So we use what's called a taper balun, sometimes called an infinite balun. We start out at about 50 ohms here and taper, and now we're 120 ohms parallel. This ends up somewhat setting how long your cavity is going to have to be behind it. But we'd set it up one way, and we're left-hand circular polarization. Do it the other way, your right hand, or as Tom Clark used to say, you have right and wrong polarization. And that's one that I do for the U.S. Navy to mess up monopulse radars, but that's another story. Well, this guy talks me out of a pair of these. Again, they were made for my own personal use. And he was kind of fuzzy about what he wanted, so I sent him a pair. I'm at Xenia last year, and he shows up and says, remember those antennas? Let me show them to you. And they're on an electronics intelligence satellite. They're now in orbit. I'm going, what? That's not space qualified material. We put it in a vacuum for a week, we're happy. Now, this is another, we had the Vivaldi antennas. This is another Vivaldi antenna, and one of the big challenges is to get two of them to slide together so that you got vertical and horizontal. Well, when you slide them together, you cut this in half, and that doesn't make, I never could figure it out. This guy in Florida has been harassing the bejeebies out of me to do crossed Vivaldis. Kent, I don't understand your problem. You can buy them from China. So he bought some Chinese ones and sent them to me. Now, I guess I have to be careful. Let's say, calling this antenna a piece of defecation is insulting defecation. This guy averages 3 dB return loss. For those of you who are into SWR, that means it averages about an 8-to-1 SWR. If you've ever done any PCB microwave layout, they terminate the line with a radial stub. A radial stub works on one frequency. And this is a broadband antenna. But all the little doohickeys slid together. So using my Vivaldis and their slotting techniques, I've now got some crossed Vivaldis. So I'll have to ask for your forgiveness. I have stolen intellectual property from China. A few of you remember Michelle, W5NYV. We discussed about 10 years ago the idea of converting these into dish feeds. If we put a little 90-degree hybrid like the ones that are available from mini circuits in there, drive the two vivalities 90 degrees out of phase, we can now have a very broadband circular polarized antenna, which would work good as a dish feed. So this is a 10 gig vivality but that would become a new dish feed and could work over at least 3 ham bands. If we pay big money, we can get it over 4 ham bands. Dish materials. This is in black and white because it was a long time ago. This is a picture of Voyager. That is a 10-foot carbon fiber dish. They took it out on the antenna range, tested it, it met specifications. As a weight savings, it was never metallized. Those pictures came back from the outer planets on a carbon surface dish. Please tell me again that stealth aircraft are made out of carbon fiber because it's radar absorptive. Once you get above about 1 gig, carbon fiber looks just like sheet aluminum. This is known as a scimitar antenna. It looks like a scimitar sword. The inside radius determines the highest frequency. The outside radius determines the lowest frequency. And it's very happy working on its harmonics. The Apollo spacecraft were covered with these. They were using them on all frequencies on both the Apollo spacecraft and on the service module, sending data back. They're a great broadband frequency antenna. We were doing some for a C-130, so I made several up. You saw the one that was there made out of carbon fiber. I guess I need to back up one. We had a question. It's really challenging to solder carbon fiber, okay? Believe it or not, for a demo at one of the antenna contests, I showed up with a carbon fiber Yagi antenna. One, we had copper mesh all the way through it. One, this has only got about 1 inch of carbon mesh in it, so I could have something to solder to. And then I had the one that was solid copper. On the antenna range, we could not tell the difference between the three. So carbon fiber works pretty good. That one right there. The input impedance of this guy is about 20 ohms. So it's a very low impedance input. I'm going to get this figured out yet. Getting a boom mic, I guess. Okay. So we're back to using a version of this where we use a taper balun again, although in this case it's just a taper line. And I'll make this end 50 ohms, or actually look more like the other way. We'd make this end 50 ohms and then slowly taper to 20 ohms. And then we get a broadband match on the antenna and we get something that works over many gigahertz of frequency range. I stated I didn't like helices. I don't like ham helices, I guess would be the best way to put it. I've had well over 100 of them on the antenna range, and less than 10% are circularly polarized. Just because you made it a curlicue, it is not circularly polarized. This is an actual NASA one, part of an uplink system. They have an insulated boom, insulated spokes going out, and keep the line isolated. When I have a radio wave traveling down along a wire like this, it travels at about 95% of the speed of light. Some variation there depending on diameter and if you got paint or anything else on it. But guys will build these. I just put that transmission line on a dielectric. It's now going to be moving at about 60% the speed of light. Now, I'm not saying you can't compensate for it, because I just used a formula that we took out of a textbook, which assumed that the coil is in free space traveling at 95% the speed of light, and now it's traveling at about 60. What happened to your axial ratio and turns ratio? But it's easier to make this way. I'm not saying you can't compensate for it. All you have to do is know the dielectric constant of this plastic. Next time you're down at Ace Hardware, ask them what the dielectric constant of their PVC plastic is. Oh, I'm smarter than that. I looked it up on the internet. The standard procedure for measuring dielectric constants of plastic is to measure it at 1 kilohertz. I can assure you by the time it gets to this frequency, since I've made these measurements, it's dropped about 30%. Now, another thing is you can make a helix that looks like a nice helix, put it out in the antenna range, and axial ratio is if I take it and I turn it, how much does gain change? If it changes less than 1 dB, we pat you on the back. If it changes less than 3 dB, you can call it circularly polarized. I have seen in excess of 20 dB. That's roughly equal to the axial ratio of a Yagi antenna. What you can end up doing is taking these, and I did it again, and start trimming off the tip, 1/8 of an inch at a time, maybe 1/4 of an inch on a 2-meter one. And you will now change the axial ratio of the antenna. And you can find a place where it's actually circularly polarized, but just where you stopped ends up making a difference. Another antenna I have an issue with. It was learned 60 years ago that if I take a log periodic and I bend the elements forward about 30 degrees, it'll work on its third harmonic. You see this very commonly on TV antennas because channels 7 through 13 are the third harmonic of channels 2 through 6. There is currently an antenna made by a company with a name similar to a cousin of a moose, which thinks that you can make a log periodic with straight elements work on the third harmonic. If you happen to have one of those antennas, turn it around and point the ass at the satellite. You will find the signals get stronger. I've had a discussion with the guys on that, and they're saying, we're selling them well, what's the problem? But this is one that was actually made, one of my AMSAT type versions, and this is a 2-meter, 440 log periodic designed to work on its third harmonic. And it's been published. I probably need to write a better write-up on it sometime, but it's easy to use. We were discussing planar disc antennas, again, a super secret design from the 1930s. Speaking of which, I recently got a very nasty letter from Turk Antennas saying that I had stepped on their patent. I got out a book showing how to build a TV antenna to build to watch the experimental television transmissions from the Empire State Building during the 1939 World's Fair. That antenna design was in the 1939 book. Sent copies of it to their lawyers, and I haven't heard back. But this is the planar disc. I've made them in different sizes, and I've got some real little small ones that will actually work as a 10 gig omnidirectional antenna. So go down to your favorite dollar store, get you some 18-inch pizza pans. You want the steel ones. They're much easier to solder to than the aluminum ones. Pardon, David, aluminium ones. Mount them as close together as you can right here, and you now have a 2-meter through 1200 meg antenna. Something, I've got one of these hanging in the attic of my house, and it goes down to one of my scanners. There's one that I made out of pieces of PC board cut round. Here's one that these are used for direction finding. This is known as the sum and difference techniques. Here we have two antennas and they sum together, these two antennas are 180 degrees out of phase. And there's the 220 version up, 2.4 gig version up there. We've done some testing with them in some labs. And this is what happens when you sum the two antennas together and you get additional gain. When you have them out of phase, you get a null in the middle. So the bottom one right now is being field tested in the Ukraine. The frequency is for GPS. So you hook up the bottom one to your software-defined radio or one of the other ones, and you listen to the Russian GPS jammers. This locates it to about 20 degrees or so. Now you know about where it is, so you hook up this one that gives you a null, and now you can locate it to about 1 degree. Send a couple of mortar shells down that line and see if it gets quiet. We could improve the side load patterns a little bit by putting radar absorber on the back of those antennas. There's some wraparound energy going there. And radar absorber tends to be pretty expensive. But if you get some of those sheet magnets that, put Acme Lawn Care, or the smaller ones are on business cards, this is iron-loaded rubber. It's not as good as the $100 a square foot stuff, but it ain't bad. So this is a cheap source of radar absorber. You got an amplifier that works great until you put the lid on it and you trap everything. Well, go take some magnets off of the fridge and put them in there, and maybe you'll stabilize it when you put the lid on. Oh, this was a fun one. I have a missile. I have an antenna on the tail of the missile. I very carefully and meticulously look at its pattern. Then you light the motor and you have 20 feet of plasma coming out the back. What happened to my antenna pattern? So we were doing some pattern measurements while the motor was running, and we might have had this one just a little too close. This is a 435 meg patch antenna. I've been wanting to make these for years. The question is, how do you solder coax to aluminum foil coated styrofoam? This is the styrofoam sheathing that you get to put some insulation in the walls of your house. Costs about $3 for a 4 by 8 foot piece. And what I finally figured out was I did it again. You get a piece of sheet, tin, brass, your choice. And over in the next aisle, they sell the aluminum tape for holding stuff together. So this has got a little piece sticking down, put some of the aluminum tape around it, and then I do the same thing on the back side, and that's how I attach the coax connector to some tape, and you can make some big patch antennas. So nothing like have something that sits flat in your attic and you can work AMSAT with it. Here's another one. These are some 1269 antennas made just for AMSAT, available to get down. And what I'm trying to show here is you don't have to put all the elements on one boom to get circular polarization. You can have two antennas close together, one vertical, one horizontal, and get CP out of that. Here we've got one horizontal, one vertical, and you've got circular polarization. Well, it's right-handed. I want left. Well, just unbolt this, turn it around, flip it the other way, and now you got the other polarization. Nearly 20 years ago, not very far from here, there was an AMSAT convention, and I did a talk on this, and I guess it's time to remind a few people of it. And that's when you mount Yagis. When you mount a Yagi and you stick a pole right through the middle of it, you get a coupling effect, and essentially it makes this element and this element appear longer. You could allow for this by trimming some elements off, but much better ways of doing it. The headache comes with the guys who like to put up the cross Yagis and then they use fiberglass boom coming across, and then run the coax back along the boom. Well, the coax is an electrical conductor. You've still done the same thing as having a metal boom. We put these on the antenna range. We actually made the measurements, and we found that when we used, we mounted the antenna X fashion, ran the element as close between elements as you could, used a metal mast, and then ran the coax back along the metal mast, the circularity distortion was about 1/4 of a dB. So now you're not disturbing the antenna, you don't have the coax running out the back, you haven't had to find a strong fiberglass, and it still works just fine. So this is a good way to mount them. I'll let him get his reference. Okay. This is one I'm working on for another plan. I kind of fell away, but this is just one thin sheet of circuit board material. And the idea is that this is a lot cheaper to make, real easy to make, and then you mount it about 1/2 inch above user supplied sheet aluminum. And this becomes an uplink antenna. And again, you'll note that I've picked a design that gives me about 100 ohm impedance here. Bring them back, I'm 50, 50 back to 100, 200s back to 50, and so forth. So there's my power divider. Tail warning radar dish out of a B29 and a little log periodic feed. So it gives me nice broadband for used on 2, 3, 5, and 10 gig. And my antenna range, when I've got it set up and using it, I've got about 300 feet I can work with. So, comments, questions, insults? That's silent.
Speaking of antenna coupling, reminds me of all the social media posts we see where people have their arrow antennas and mounted within that their phones, their radios, and all sorts of devices in between the elements. But it looks cool.
It's simplistic. Duct tape is a time-honored tradition. I also have a 1269 PCB Yagi that mounts onto the arrow antennas at about a 45-degree angle. And on my website is the files for printing out the clips that hold it onto the boom.
So another time-honored ham tradition is fox hunting. And I'm wondering if you have any thoughts about a convenient handheld 70 centimeter or 2 meter directional antenna.
Well, we're looking at, you're looking at my next column for CQ magazine. You can make some little 2-element Yagis who do them like this and have them find approximately, then switch like this and null it, and you can get 1 degree resolution. The biggest headache is explaining to the guys how to make the power dividers to bring them together. And one of the easiest things to do is to take those little couplers that are made for your TV set, so you can put 2 antennas on one or 2 TVs on the same one. They're a little hybrid transformer. They don't care what impedance they are. So you can use them as, take the 75 ohms and just put some 50 ohm adapters, or take the hybrid transformer out and put it on 50 ohm connectors. It doesn't care. It's a 2-to-1 transformer, so it doesn't care what the impedance is. More silence. I return control of this menagerie to you.
All right, thank you very much, Kent.